the sum of symmetric and skew symmetric matrix. Already in the previous meeting I have done the first part. The given matrix A was of the order 2 by 2 and fourth part is the same. So that you can do yourself. Now the second part and third part, both the given matrices are of the order 3 by 3. I'll do the third part, and let me tell you that this question 10 third part was asked in CBSE 2008 exam for 4 marks. So let us try this third part. Question 10 third part, given is a matrix A as 3, 3, 3 minus 1, minus 2, 1, and minus 4, minus 5, 2. Let me check again. 3, 3 minus 1, minus 2, 1, minus 4, minus 5, 2. Yes, you should always check the matrix when you write it. Okay, we have to express A as sum of two matrices, say P and Q. That's what is required. Okay, where one of them is symmetric. So let's say where we'll express it in such a way where P is a symmetric matrix and Q will find that Q is skew symmetric matrix. Now if I choose P equal to half A plus A dash and Q as half A minus A dash, where of course A and A dash both are the matrices of order 3 by 3. What do you find here? P plus Q, half common, you get A plus A dash plus A minus A dash cancels, so you get half the times 2A, that is A only. So if I choose P as half A plus A dash and Q as half A minus A dash, then at least A will be equal to P plus Q. That has been verified. So now I shall find P and Q and show that P is symmetric and Q is skew symmetric, and our job is done. So let us find P. What is P? Half A plus A dash. That is half out. What is the given matrix A? Given matrix A is defined as, you put a square bracket, A is 3, 3 minus 1, minus 2, 1, and minus 4, minus 5, 2. And so what will be A dash? Take the transpose of it. The elements of the first row, that is 3, 3, minus 1, you write in the first column. The elements of the second row, that minus 2, 1, you write in the second column. And the elements of the third row, minus 4, minus 5, and 2, you write in the third column. So we get P equal to half A plus A dash. Just add the 2. So you get P equal to, by adding the 2, 3 plus 3 gives you 6, and 3 minus 2 gives you 1, and minus 1 minus 4 minus 5, and likewise you add the other elements, you get 1, minus 4, and minus 5, minus 4, 4. Let me check it again. Column wise, 6, 1, minus 5, 1, minus 4, minus 5, minus 4, 4. So that's what you get P, multiplying each element by half. You get 6 by 2, that is 3, half, minus 5 by 2, half, minus 2 again, minus 5 by 2, minus 2, and 2. So you call it 1. So we get the value of P. Work out the value of P dash. That is, write the elements of first row in first column and so on. So writing the elements of first row in first column, we get 3 half minus 5 by 2, and elements of second row half minus 2 in the second column, and that of the third row minus 5 by 2 minus 2 in the third column. what do you find from 1 and 2? From 1 and 2 you observe that the elements of the first row in both are 3, half minus 5 by 2, half minus 2, 2 in the second row, and the elements of the third row are minus 5 by 2, minus 2, 2. Yes. So what do you find from 1 and 2? That P dash equal to P. So should I conclude that P is a symmetric matrix? So we have already got the first matrix P, which is a symmetric matrix. Now let us work out P dash. The second matrix Q, defined as half A minus A dash. Substituting the value of A and A dash. What is the value of A? The value of A is 3 minus 1, minus 2, minus 2, 1, and minus 4, minus 5, 2. And minus, what is A dash, which we have already worked out as 3 minus 2 minus 4, and 2 negative 2, 3 here, 3 negative 2, negative 5, and negative 1, 1, 2. And now you subtract the 2, that means subtract the corresponding elements. Subtracting the corresponding elements, you get Q equal to half. Subtracting the corresponding elements, you get 0, 5, 3, minus 5, 0, 6, minus 3, minus 6, 0. Multiply each element by half, so you get Q equal to 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3, and 0. And this is Q. We want to prove that Q is skew symmetric. So let us work out the value of Q dash. Take the transpose of it. The elements of the first row 0, 5 by 2, 3 by 2 in the first column. Second row minus 5 by 2, 0, 3 in the second column. And minus 3 by 2, minus 3, 0 in the third column. And take a minus sign common throughout. You get 0, 5 by 2, minus 3 by 2, minus 5 by 2, 0, 3, and minus 3 by 2, minus 3, 0. Now just compare it with Q. Is it same as Q? 0, 5 by 2, 3 by 2, 0, 5 by 2, 3 by 2. Please make a correction here. In the first row, when you take minus common, you get 0, 5 by 2 and plus 3 by 2. And now if you compare, you get this is nothing but minus Q. So we have proved that Q dash equal to minus Q. So obviously Q is a skew symmetric matrix. So what do you find here? That A can be expressed as A, we can express as P plus Q, where P is a symmetric matrix and Q is a skew symmetric matrix. So now finally, for answer, I should write A equal to the value of P and Q. What is the value of P? The value of P is 3 half minus 5 by 2 and half minus 2 minus 2 and minus 5 by 2 minus 2, 2. This is P. And plus what is the value of Q? The value of Q is 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, and the elements of third row minus 3 by 2, minus 3, 0. So yes, I could express A as sum of two matrices where the first one is symmetric and the second one is skew symmetric matrix. If A and B are symmetric matrices, if A and B are symmetric matrices of the same order, then AB minus BA is skew symmetric or symmetric. Obviously, AB minus BA in general are not equal, so cannot be zero matrix, and we are not sure about whether it will be identity or not. Let me check first of all what is the transpose of AB minus BA. If I find it is exactly same as AB minus BA again, I'll say it is symmetric. If it becomes negative times of AB minus BA, I'll say it is skew symmetric. So you know the transpose of difference of two matrices is separately the difference of their transposes. So I can write AB minus BA dash is AB dash minus BA dash. Now AB dash, that is the transpose of the product, will be the product of their transposes but in the reverse order. So AB dash will be B dash into A dash and BA dash will be A dash into B dash, that is in the reverse order. Now as A and B, as A and B are already given to be symmetric, so A dash can be replaced by A and B dash can be replaced by B. So you get here BA minus AB. Obviously it is not same as AB minus BA. Take a minus sign common, you get AB minus BA. So what do you find now? That AB minus BA can be transpose of it. AB minus BA transpose is expressed as negative times AB minus BA. So the only possibility is that it is a skew symmetric matrix. Hence, the given matrix is skew symmetric matrix. That is, A choice is the correct answer. Next one. If A is cos alpha minus sin alpha cos alpha, and A plus A dash is identity matrix, then find the value of alpha. A is given to be cos alpha minus sin alpha cos alpha. So what will be its transpose? Just interchange the row and column. The elements of the first row cos alpha minus sin alpha in the first column. That of the second row sin alpha cos alpha in the second column. Now A and A dash both are square matrix of the same order 2 by 2. So I can easily add them. So what is the value of A plus A dash? A plus A dash, you get cos alpha plus cos alpha 2 cos alpha minus sin alpha and sin alpha gives you 0. Again sin alpha and minus alpha gives you 0 and cos alpha and cos alpha equal to 2 cos alpha. A plus A dash is this, but this is given to be equal to the identity matrix. It is given. So 2 cos alpha 0 0 2 cos alpha equal to, what is the identity matrix of second order? 1 0 0 1. Yes, 0 zeros are equal. So what do you conclude from here? That 2 cos alpha is 1, cos alpha is half. So what is the required value of alpha? Alpha is 60 degree or pi by 3. So which choice is this for you? You check, it is your B choice.